Hello students, in the last class we discussed about the ozone. In this class we can study about the allotropes of the sulfur, that is sulfur and its compounds. Before going to sulfur and its compounds, first we discuss about the allotropes of the sulfur. Sulfur mainly forms two important allotropes. Sulfur mainly forms two important allotropes. Namely, one is an yellow rhombic. This is the yellow rhombic, also called as an alpha sulfur. And second type is the monoclinic sulfur. Yellow rhombic and monoclinic sulfur. It is called beta sulfur. These are the two important allotropic forms of the sulfur. Namely, yellow rhombic, that is rhombic sulfur, monoclinic sulfur. Rhombic sulfur, also called alpha sulfur, monoclinic sulfur, commonly called beta sulfur. First, you consider the rhombic sulfur. That rhombic sulfur, it is an allotrope of the sulfur which is yellow in color. That rhombic sulfur is yellow in color. That rhombic sulfur, it is obtained by evaporating. That is obtained by evaporating the solution of sulfur. Evaporating the solution of sulfur in carbon disulfide. This is the preparation. Rhombic sulfur is obtained by evaporating the solution of sulfur in carbon disulfide. This rhombic sulfur is insoluble in water. This is insoluble in water, but dissolves to some extent in benzene, alcohol, and ether. To some extent dissolves in benzene, alcohol, and ether, and readily soluble, that is more soluble in carbon disulfide. Insoluble in water, that is to some extent soluble in benzene, alcohol, or in ether, but more soluble, readily soluble in carbon disulfide. This alpha sulfur, that is rhombic sulfur, it is stable. It is stable below 369 Kelvin. Only below 369 Kelvin, this rhombic sulfur is stable. If you raise the temperature, this transforms to monoclinic sulfur above 369 Kelvin. If you maintain a temperature of above 369 Kelvin, that rhombic sulfur changes into the monoclinic sulfur. That rhombic sulfur only stable at 369 Kelvin. This is about the rhombic sulfur. Second one is monoclinic sulfur. This monoclinic sulfur is colorless crystalline solid, colorless crystal. Rhombic sulfur is yellow crystal, while monoclinic sulfur is colorless crystal. It is soluble, this one also, monoclinic sulfur also soluble in carbon disulfide. This is prepared, that monoclinic sulfur is prepared by melting rhombic sulfur. By melting the rhombic sulfur, we get the monoclinic sulfur. This is stable, monoclinic stable, sulfur is stable above 369 Kelvin. Rhombic sulfur is stable below 369 Kelvin, while monoclinic sulfur is stable above 369 Kelvin and transforms into this monoclinic sulfur transforms into alpha sulfur, that is rhombic sulfur, below 369 Kelvin. Below 369 Kelvin. In case of the rhombic sulfur is stable below 369 Kelvin and transforms to beta sulfur, that is monoclinic sulfur, above 369 Kelvin. While monoclinic sulfur is stable above 369 Kelvin. If you maintain a temperature below 369 Kelvin, then monoclinic sulfur transforms into rhombic sulfur. Then, at that, this most important point, at 369 Kelvin, even for the competitive, this is very important, this temperature is very important. At 369 Kelvin, both the forms, that both rhombic and monoclinic form, both the forms are stable. At what temperature rhombic and monoclinic are stable means only at 369 Kelvin. At 369 Kelvin, both the forms are stable, and that temperature, the 369 Kelvin, we are called as the transition temperature of sulfur. The transition temperature of the sulfur is 369 Kelvin. At 369 Kelvin, both rhombic and monoclinic sulfurs are stable, while below 369 Kelvin, the rhombic sulfur is more stable. Above 369 Kelvin, monoclinic sulfur is more stable. If you maintain a temperature of 369 Kelvin, both the forms are stable. This is about the allotrope. Next, we consider the structures of both that allotrope, that is rhombic and the monoclinic sulfur. That both the rhombic and monoclinic sulfur, they have the S8 molecule. The molecular formula of the rhombic and monoclinic sulfur is S8 formula. In these S8 sulfur, 8 octaatomic, sulfur is octaatomic. These S8 molecules, they packed to give the different crystal structure, different crystal structure. The S8 ring of the both forums, they are puckered. That means they are closely packed and has a crown shape. The structure of the rhombic and monoclinic sulfur is crown shape. That is, crown shape means this is the sulfur atoms. This is the crown shape structure. The crown shape structure of that both rhombic and monoclinic is the crown shape, and bond angle value in that crown shape is 107 degree, and bond length, any sulfur bond length is of 204 picometer. This is the crown shape. Then other structures of that sulfur containing 6 to 20 sulfur atoms. Other modifications of sulfur, generally octaatomic S8, Other modifications have been synthesized that sulfur containing 6 to 20 sulfur atoms per ring have been synthesized. In addition to Si, sulfur atom, that ring containing 6 to 20 sulfur atoms per ring have been synthesized. For example, cyclo S6, that cyclo S6 has the chair form. It has the chair form. Cyclo S6 structure has the chair form. That is octaatomic. S8 means the cone shape. While cyclo S6, if they mention the cyclo S6, then that cyclo S6 it has the chair form. The structure of that cyclo S6 is the chair form. This is about the cyclo S6. Then at high temperature, at very high temperature, that is elevated temperature of 1000 Kelvin, at very high temperature, S2 diatomic, sulfur in the diatomic, S2 is dominant. And is paramagnetic like O2. Paramagnetic like O2 molecule. Similar to O2, S2 is also paramagnetic because S2 contains the two unpaired electrons. S2 contains the two unpaired electrons in antibonding orbital, that is pi star 2px, and pi star 2py. Like similar to oxygen, sulfur also contains the unpaired electrons in the antibonding molecular orbital. At very high temperature, S2 is dominant. If they mention at high temperature sulfur exists in which form means it is diatomic only, not an octaatomic. In the normal conditions only, sulfur is octaatomic. But high temperature, it is diatomic and is paramagnetic in nature. This is about the allotropes of the sulfur. In the next class, we can discuss about the compounds of the sulfur. There are two important compounds, one sulfur dioxide and sulfuric acid. Next class, we can discuss those compounds of the sulfur.